Hi, it's Jocelyn. This is Advent of Code Day 16. Alright, so as you leave the cave and reach open waters, you see a transmission from the elves back on the ship. We have just one line of strange characters, it looks like. Alright. Okay, so we convert it into binary, and then each packet begins with a standard header. The first 3 bits encode the packet version, next 3 bits type ID. Okay. Alright, so there's a lot going on here, but we can start by just decoding the string, I guess. So we have a little thing here, so I'm not sure if there's a better way to, let's see, so don't want to like literally just do a match thing there. So there's 2-digit in base 16, and then let's figure out how to print a binary number. Okay, like that. So we can say format that number as binary. And let's see what that looks like. We do have an example, it looks like, in here, so and I just can't type. Okay, so there it says it's 1101. Okay, so this looks right. I can actually I'm just going to copy this and make sure that it matches exactly this string. Which, let's see. I'm a bit confused. Let me try this again. Okay, actually I'm just going to copy this over here. Right, that doesn't match. It needs to be exactly of length 4. Probably would have been faster. With leading zeros, look at that. Probably would have been faster just to use the table there. Alright, so Okay, this is just not working. Okay, yeah. So I think I figured this out now. Let's see if that got that right. Yeah, so now they match. Beautiful. Okay, so going on to the next part. 3 bits labeled V. Okay, so the first 3 bits encode the packet version, the next 3 bits encode the type ID. So we're going to start with I equals 0, and then we're going to parse it. So while I is less than decoded dot len, actually we're going to convert decoded into characters now. I guess that would just be chars. There we go. So at first, there's different states we can be in parsing. There is actually no, we don't necessarily need this yet. We might need it later. But okay, so parsing the version number. When we're at here, we're going to parse the version numbers. So all right, and then okay. First 3 bits encode the packet version, and the next 3 bits encode the type ID. So type is equal to decoded. Starts at I plus 3 and goes to I plus 6. These 2 values are numbers. All numbers encoded in a packet are represented as binary with the most significant bit first. For example, a version encoded as binary sequence 100 represents number 4. Okay, so we would now want to convert this into, I guess, into a number. So first of all into a string, and then actually, let me just take a function which does this. So hub function let's see, chars 2 num, we'll call this C, will return a number. Now we need to figure out how to go from binary into it's actually, there's probably just like a, you can probably find this. That would just be parse, but that would be a, okay, let's see. Lots of things I don't know here. Well, this is probably helpful. from string radix. I guess we saw this earlier. So we'll do I64 from string radix, and that will be this, and it will be in base 2. Okay. And the second thing is just the, I guess we'll call it type ID because we can't use the word type. So this will be version is equal to chars to num, and this will also be chars to num. And these need to be references. I just want to see what we get for the first couple ones. Then we'll say I plus equals 6. Actually, yeah, I'm just going to panic here because we're not done. And it accepts a reference, not a string. Okay, and so we got that correct. It prints 6 and 4. Oops. It prints 6 and 4 just as we expected. So next we're figuring out what A is. The 5 bits labeled A start with 1, not the last group, keep reading, and contain the first 4 bits of the number. Okay, the binary number is padded with its leading zeros until its length is a multiple of 4 bits. And then it is broken into groups of 4. Each group is prefixed by 1 except the last group. Okay, so that's, let's see. Right, it starts with the 1, so it's not the last group. B is not the last group, so you keep on reading as well. And the 5 bits labeled C starts with 0. So that's the end of the packet. It's another 4. Okay, so if type ID is equal to 4, then it's a literal value. So we see if it continues, which is true if decoded at I is equal to 1. And then the value is just decoded I plus 1. Looking here, 1, 2, 3, 4. Is that right, or am I off by 1 here? I think I'm off by 1 because there's 4. Yeah, there should be 4 digits. So there we go. And then I'm just going to print that. And this again is going to be chars to num. And that needs to be a reference. Okay. So we're going to actually loop here. Or we can say continues equals true, while continues and then we're going to say I plus equals 5 because that includes that 1 over there. Okay, so here, this isn't hiding. My shortcut's not working. I don't know what I messed up here. I can just, let's see. Can manually hide it like that. There we go. So we have true 7, true 14, and false 5. I'm just going to check the last one. 4 plus 1 is 5. That looks right. And then it says the 3 unlabeled 0 bits at the end are extra due to the hexadecimal representation and should be ignored, which means if there aren't enough left, then we should just break. So if okay, so we can say, well, I plus, there's going to be up to 3 remaining ones. In this one. Okay, so to actually do anything, we need to at least read the version and the type ID. So we need at least 6 characters. So I think that's right. Okay. And now we need to, I guess, actually figure out what the total value is. So actually what I'm going to do is I'm going to say let mute val is equal to string.new, and then I'm going to say val plus equals, and then decoded, and then at the end we're going to say let val equals chars to num. Oh yeah, this should just be a vec. And we can say val, and we can print that as well. And we're just checking here that we're getting 2021. Let's see. There's probably a way of doing this smarter, but I'm going to just say just going to say that. And we saw that was correct, so that's fine. We don't need to do more of that. And they're all references, so we need to make them not references. Thankfully, chars can be copied. And here we say it says 2021, so that's wonderful. Okay, so going on to the next part of this. This goes on forever. Any other type of packet, any packet type ID other than 4 represents an operator. An operator packet contains 1 or more packets to indicate which subsequent binary data represents. An operator packet can use one of 2 modes indicated by the bit immediately after the packet header. This is called the length type ID. Okay, so else if type ID is 0, then the next 15 bits are a number that represents the total length in bits of the subpackets contained by this packet. That is a mouthful. Or if it's 1, then the next 11 bits are a number that represents the number of subpackets immediately contained by this packet. So we can say here I plus equals 15, and in this case I plus equals 11. I'm just going to copy this text here because seems like something I'll want to look back at later. Okay, so we're happy with our first example. I'm going to move on to the second example. And oh, I missed that. Okay, any packet with a type ID other than 4 represents an operator. An operator itself contains one or more packets. So first I'll put it there. And I guess this can probably recurse, so I'm going to just make another function here. These going to be public. Function parse. We'll figure out what it takes, but for one thing it takes I, which is the mutable usize, and it takes a decoded string, which is a bunch of characters. Okay. And we're going to copy all of this into the parse function. Oh, please tell me that it's not going to make me add stars to all of these. Anyway, I'm going to say parse and mute I and decoded. So first of all, I can remove all of the ampersands here for decoded, and it's really gonna make me do this, isn't it? It sure is. This is so silly. Oh, I was wrong about the references. Okay. Contains one or more packets. To indicate which subsequent binary data represents subpackets, an operator packet can use one of two modes indicated by the bit immediately after the packet header. Okay, this example will probably help. So it's just this bit right here after the type. Oh, it's not the type ID, it's the length type ID. That was what was confusing me. So that's just decoded at I, because we've done their plus equals 6 there. And then we can say if length ID is equal to 0, then there's this. And if length ID is equal to 1, then there's that. Okay, if it's 0, the next 15 bits are a number that represents the total length of bits in the subpackets contained by this packet. So I don't really know what that means. Let's see. Oh yeah, that again. I don't really know what that means, but we can sure do that. Actually, I'm going to say A plus equals 1 there. Then we can say length is equal to chars to num decoded from I to I plus 15. All right. And if it's 1, the next 11 bits are a number that represents the number of subpackets immediately contained by this packet. Okay, so L is that 15-digit number. The 11 bits labeled A contain the first subpacket, a literal value representing the number 10. Okay, so we can just okay, so that's saying we're supposed to read 27. And that, okay, so okay, so we're definitely doing parse. We're definitely passing I, we're passing decoded. So that's, we want to stop when we're at I. Okay, I'm going to make this a U size because we don't have negative numbers. Okay, so while I is less than stop at, we're doing this. And I think we can assert that I is equal to stop at the end. I wish I could stop ads. Okay. Oh, so sorry, other way around. So we're going to say literal here, and I'm going to say, and also print the length. Yeah, let's go from there. Okay, so that's promising. It says 27, and then it says literal 10, and then it says literal 20. But our assumption there is not working. Let's figure out why that is. I said a print there, that's annoying. Let's see what I and stop at are. Oh, maybe it's one past. That would make sense. Oh, no, it's just way more. Okay, so I'm gonna just actually copy from the example just to see what's going on here. So yes, that makes sense. So it's starting, the first one starts at 22, and you can see over the bottom that is character 23, so that's correct because Vim is one indexed and where's your indexed. And then here it's going to starting at 34, which is 33, that's good. And then after parsing the 20, oh, I see what I did wrong. We're not including the 15 there, so just moving that a line down should resolve that issue. Okay. Anyway, it's continuing. So I'm going to go back to reading what these zeros are about. After reading the 11 and 16 bits of subpacket data, total length indicated an L is reached, and so parsing of this packet stops. And these zeros Okay, so it says literal value packets. Okay, to do this with leading zeros. No, that's all fine. They're due to hexadecimal, it says, but like that would be at most. Oh, I guess it needs to be okay. Yeah. I'm just gonna say if parse, okay, so if decoded.len minus I, so the number of characters remaining is less than like 20 or something, I'm being super hacky here, then and parse number, I'm just going to see if it's 0, and if it's 0, then we're just going to give up. Sorry, chars_toNum is the function name. Oh, this is such a mess. All right, so now it looks like we finished nicely. There's another example, so let's do that one as well. Oops. Oh, that's an operator packet. Okay, so oh, I is 1 here, so I need to figure out what the 1 does. Okay, if the type ID is 1, the next 7 bits represent, or a number that represents the number of subpackets immediately contained by this packet. Okay, so for j, we can't use I, that's already used, in 0 to len, we're going to parse those. So parse, take our I and take decoded. I'm just going to write here start and end, just so that we can see if they're contained correctly. Okay, so it says that in the example it says it's a length ID, which indicates that the length is a 15-digit number. Yeah, okay. Oh no, I'm looking at the wrong example. Okay, so the bit I is length type ID, which indicates that the length is an 11-bit number representing the number of subpackets. There are 3 subpackets. And so all 3 of these literals should be in that subpacket, but they're not, so we got something wrong here. Oh, I said 1 to len. I don't know why I said that. I meant 0 to len, but not including. And I made a big deal about j, but we don't even need j. Great, anyway, we see that the example is right now. Okay, now to actually getting the problem. Okay, so parse the hierarchy of packets throughout the transmission, add up all the version numbers. So this requires actually returning something now. So version sums is equal to 0, and we can say version sums plus equals version, and then wherever we're calling parse, we need to say version sum plus equals that. I'm just going to do version sum instead of version sums. Version sum plus equals that. Then let's see. And I believe this is a U size. Okay. There are some examples. We are going to do all of them because there is so much subtlety here. So the first one is 16. Oops, what I do there. The first one is 16. The second one is 12. The third one is 23. And the last one is 31. Oops. Let's see if we get any of these right. Oh, we need to return the version sum. Which is mutable. All right, so all of those examples pass, and so we can move on to part A and see if we get a valid output. Okay, it's saying it's 833, which is correct. All right, continuing to part 2. All right, so we have different types, and we're trying to get the value of the transmission. Okay, so we either have sum, product, minimum, maximum, greater than, less than, or equal to. This is kind of tricky to do in an elegant way. So what I'm going to do here is I'm going to make a operator state enum, which can be either any of these things. So with sum, it can be sum, product, minimum, maximum, greater than, less than, or equal to. So greater than, if the value is 1, if the value of the first subpacket is greater than the value of the second subpacket. Okay, so that's just going to return. I'm going to actually just store this as a Beckett represents the Beckett view size. So it will contain all of them, and then when we're evaluating it, it will just be whether the first is bigger than the second. And same for equal. Okay, so we have our implementation for operator state. It's going to take an insert. Yeah, there's going to be an insert function which takes the mutable self and then a value, and then does something for all of them. So for all of these, what we're just doing is we're just pushing the vowels. The other ones are a little bit easier, so if it's the sum, then we're doing, oh yeah. What's the name for this when we're redoing something? I'm just going to call it state. Okay, so state plus equals val state times equals val state is equal to state dot min val, and their maximum is similar. State is equal to state dot max val. And yeah, that's all of them. And then there's also going to be a function val, which takes self and returns a usize, which I will solve in a second, but we're getting some errors. Oh, but they're on the wrong lines now. So I'm just going to copy this thing again. Yeah, actually, it's easier to go from here. So match self. So we're considering all of the different states, or all the different operators it could be, and for these we're just returning the value. The first 4 we're just returning the value. And for these we actually have slightly more complicated things to do. So for greater than, we're returning, so if vals 0 is greater than vals 1, then we're returning 1, and otherwise we're returning 0. And the remaining ones are not too different. Less than and equal than, and we can assert that these are always the same, so, or that there's always exactly 2. So assert vals.len, or something weird going on for types, so I'm going to just get this to compile first. I'm just missing that. Okay, something I did here is breaking my formatting, which is really annoying. Expected usize found that. Okay, so val is just the usize. It's kind of a weird thing to need, but we'll do it. Oh good, and these formatted now. Wonder what that was about. Okay, so now we need to create the correct operator for whatever our type ID is. So I'm going to say operator equals match on type ID. So it can be 0, in which case we're doing sum, and sum start at 0. And if we don't recognize it, we're going to panic. Wonderful. Okay, so if it's 1, it's a product. Products start at 1. If it's a 2, then it's minimum. Minimums start at the maximum number. If it's 3, then it's maximum. Those start at 0. If it's 5, it is greater than, which starts with an empty vec. And same thing for 6 and 7, which are less than and equal. Okay, so now we need to differentiate between whether we're in part A or part B, because those have those two different things. So if we are in part A, well, I'm just going to rename this to solve like usual. And have a Boolean part A, which will pass over here. Okay, so I need to pass this along as well over here. Actually, what I'm going to do here, I'm going to be a little bit clever, is to say if part A, then it's going to be a sum. It's just a way of like testing our code a little bit. Otherwise, we're going to do that. Okay, and then we're going to say operator dot insert whatever we parse. And if it's part A, then it's going to add it. Otherwise, it's going to be more clever. Okay. If it's a literal, and we are in part A, then we are returning the version sum, which is just the version. And if we are not in part A, then we are returning the value. Great. Okay. And then at the bottom here, if we're doing an operator, then we're at the end just returning the operator's value. And for part 1, the answer was 83. So what we want to see now is if the tests are passing. And we see over here that I broke something in this. So I'm just gonna, before I debug too deeply, I'm going to look at what I'm doing. So I just, oh, I said false here. These are supposed to be true. For part A. But I'm still getting them wrong. There's really not like a whole lot that's going on here. Okay, so let's just go back to the first example. Okay, so this represents an operator packet, version 4, which contains an operator packet version 1, which contains an operator packet version 5, which contains a literal value version 6. I'm just going to see what it's returning at each stage. Oh, we're not, oh, darn it. If it's an operator, we're not considering the version ID. So it doesn't start at 0, it starts at version. I think it's very likely that this will pass now. It does pass. Okay, so all of these should pass. I'm feeling fairly optimistic about this, maybe overly so, but I'm just going to run input with part B right now. All right, and we get a nice massive number. Which is right. All right, thanks for watching, and I'll see you tomorrow.